Charles actually asked me if I could say something about XSLT3 at this conference because he got advance warning that we were going to ship it on the 8th of June. So XSLT3 is now out, but I decided we've pretty well at these conferences sort of said everything there is to say about XSLT3, and I know not everyone has attended all those talks, but I didn't want to repeat myself too much. And I thought what might be interesting now at this stage, sort of having completed the process, is to tell you a little bit about how we did it. And in particular, the extensive use that we made of XML and XSLT and all these technologies ourselves in our own internal development. And eating your own dog food is a phrase that derives, I'm told, from a sort of 1950s dog food commercial where someone stood up and announced on television that his dog food was so good that he ate it himself. But a lot of people don't like the phrase, so there's an alternative. And that's perhaps appropriate for a celebration, as we've just finished 10 years of work on creating XSLT3. We certainly ought to be popping the corks a bit. So this is about how we used XSLT in the creation of not just XSLT, but the whole family of XML specs. And I've worked on other standards initiatives in the past on areas like database technology and so on. And one of the things that I always found very noticeable was that there was a real lack of user experience among the people developing the standard. They didn't actually know all the spec that well themselves because they weren't using it every day, because there weren't any implementations of it yet. And even if there were, they weren't relevant to the work of writing a specification. But with specs in the XML family, you have this very positive feedback that comes from the fact that the technology is there for producing documents, and we're producing documents. So we jolly well ought to be using the technology as we develop it to do the job we're doing. And so that's really what I want to talk about, how we actually used XSLT in the production of these specs. Three areas I'd like to talk about. I'm going to talk about the actual task of producing the documents. I'm going to say a very little bit about the task of specifying the grammar. I'm not going to say very much about that because I wasn't personally involved in it very much. There were a lot of other people who know it an enormous amount better than I do. Yep. Cheers. And then I'm going to talk a little bit about how we used XML and XSLT for managing the test suites that we created. So let's start with producing the documents. The source material, of course, is all XML, as you'd expect. I hope you'd expect, anyway. You might not be able to see the bottom of the screen, but I think the total of these specs is probably about 1 million words. So in comparison with Oxford University Press's database of academic journals, it's not vast, but it's a significant publishing task to produce that volume of material in a number of different documents that are related to each other and under very careful control, and that have some interesting technical characteristics as well, which I'll talk about. So XSLT3, I think, is about 270,000 words. I haven't seen it printed out on paper. I think Anders was the last person who ever printed a version of the XSLT spec, and he has very good eyesight, so he printed it in a very small font. So it would actually fit in his briefcase. But I think if I tried to print it at a size I can read, then I wouldn't be able to carry it. So it's a collection of related specs. And interestingly, although we worked very closely with our friends in XQuery, nearly all our production technology is XSLT. So the XQuery people were using XSLT as well. Hardly any XQuery was used in this production process. So some of the technicalities of these documents that make the publishing process a little bit more interesting. Firstly, there's a lot. I'll just highlight a few of the interesting characteristics. You might have noticed that every time we produce new versions, there's a version with diff markup. so don't try and use a keyboard standing up. So there's always a version of the document that has change highlighting on it. Now, actually, there are two different techniques that were used for doing change highlighting. One is for editors to maintain the changes manually during editing, and the other is to post-analyze by diffing the documents to find the differences. In the documents that I was editing, I always maintained diff markup manually. Some of the other editors did it by analyzing after the event. The advantages of doing it as you edit are, firstly, it can be semantic diffs rather than just syntactic diffs. So if you correct a spelling mistake, you don't really want to draw your reader's attention to that because it only distracts them. And also you can have a change history. You can record when and why that change was made. So if you look at the bottom of the document, you'll see that these are the diffs between the proposed recommendation and the final recommendation. So there aren't very many of them, and they are very trivial. But you'll see there's actually a link to a bug entry in Bugzilla that points out the problem and explains it and gives the change history of the decision on that. So that sort of takes you to the history of why the working group made that decision. And then there's references to the actual places in the document that are affected by that change, which you can link to, and then you get the change highlighting for that particular change, which, as I say, in this version are pretty trivial, but in earlier versions they were quite extensive. And the way that works internally, I'll just prove to you that the spec is developed in XML. Here's a little sample of the actual XML of the XSLT spec. I hope that's legible from where you are, but you can see it's quite rich in markup generally, which reflects the fact that all the glossary definitions are linked, there's an awful lot of cross-linkage and hyperlinkage within the specification, but also you can see here the change markup tagging at the level of links to particular bug entries and so on, to identify where the changes are. So that's just one aspect of the technicalities. Other things, syntax highlighting. You might not notice that there's syntax highlighting in the spec because we deliberately made it very subtle. This was introduced at a pretty late stage, but if you look at XML examples in the spec, let's just go to where there are an awful lot, so I don't know why it's difficult to find them. There's an example of a bit of XML in the spec. We didn't want to distract the reader, but at the same time, a little bit of accentuation with color does actually help you parse that by eye as you're reading it, and hopefully you don't even notice that they're different colors. You just read it a bit more easily. So it's designed to be a soft color scheme. That's done using the XML spectrum tools developed by Phil Fearon. And in fact, it was Charles who suggested that we do that because he'd used that technology in producing the proceedings of this conference and showed us how to integrate that technology into the pipeline we've got. What else have we got in there? Executable grammar. I'm going to be talking more about the grammar mechanisms later. Testable examples. In the XSLT spec, the only level of testing that we do is syntax checking. So where something is marked as an XML example, we actually check that it's well-formed XML. If something is tagged as an XSLT example, then we validate that it's well-formed XSLT. So there's that level of checking. In the functions and operators spec, we go further than that. Let's just show you how that works. Here's the functions in the functions and operators spec are maintained not, a lot of it is not just narrative text, a lot of it is structured data about the prototypes and the arguments and the argument types and things like that. So every function is driven by a bit of data like this. Can you read that? Shall I try and expand it? No, I can never remember how to do that. There we are. So here's the math sign function, which is a new in XPath 3.0, I think, and therefore in XSLT 3.0. So the signature is defined using structured markup as to what the return type is, what the argument types are, some properties of the function which don't even appear directly in the spec, but are used to drive some of the streamability analysis in XSLT. So the analysis of which functions are streamable is based on properties of the functions held in the catalog. And then the examples of use of the function appear in structured markup like this. So what's this sign of -0? It's -0. And that doesn't just generate the example in the spec. It generates a test case which goes into the test suite, and implementations, therefore, when they run the test suite, test that example delivers the result that the spec says it should deliver, which means either the product's wrong or the spec is wrong if they get a test failure in that case. So there's a fair bit of added value going in there. And as you can imagine, all those phases of generating tests from examples and so on, and generating the documentation are all XSLT processing. What else do we do? There's a lot of common text across specs. The obvious example is XPath and XQuery have a lot of common text between them. That's all managed by a common XML source tagged saying which spec each bit of text applies to. Fine-grained cross-linking, you saw a little bit of that. Come back. So we're not only doing fine-grained cross-linking within a spec, we're also linking across specs. The challenge there is not just sort of validating that all your links actually point somewhere, but managing change, because one spec changes, the links become invalid in another spec and so on. And what we actually do is that when you process one spec in your build, we actually create an index of all the link targets in that spec. And so we maintain an XML document which is a database of all link targets. And when you process any of the specs, it's checked against that database of link targets to make sure that they're all still current, and you get build errors if any of the link targets have changed and no longer point to anything. So rather than having to read all the other specs in raw XML when you process one spec, you actually just read that database, which makes the whole process a lot more efficient. Auto-generated appendices, graph diagrams. We use this very extensively at an earlier stage of processing of the spec. Here's the spec in the stage it was about 7 or 8 years ago. I thought this was going to open at the right page, but yeah, there's a lot of diagrams like that in the spec. Let's just use that one for a moment. So that's a diagram of a bit of the abstract syntax tree obtained by parsing XSLT and XPath. How did we generate those diagrams? Answer is we took a very high-level semantic description of the diagram that we wanted to generate, which is essentially just the descriptions of nodes and arcs on that. From that high-level description, we generated the XML form of the input language to the GraphViz tool. We then that then gets automatically translated into the non-XML form of the control language for GraphViz. We then invoke GraphViz to generate the diagram in SVG format, and then we feed the SVG format back into the document. So that's all XML and XSLT technology as well. And then finally, almost goes without saying, there's a lot of Unicode in there. Did you notice that the trig functions use sine of theta? You know, why not? We can do it, so let's do it. Let's not restrict ourselves artificially to ASCII all the time. If you look at the functions and operators spec, it also has examples in other languages, for examples of date formatting. There, for example, is what I'm told is an Islamic date formatted in Arabic. If anyone could correct me on that, please do. And Hebrew dates and Thai dates and so on. That caused us a lot of problems in the early days, and it's interesting how much the web has evolved. In the 10 years that we spent developing these specs, those problems basically disappeared. In the early days, getting that to appear correctly on every browser was quite a challenge. Today, it's not really difficult anymore. It just happens. The biggest disaster we had with this was when Jim Melton, who's an ex-query guy, not an XSLT guy, but he took on the task of converting, of creating all the baseline for the 3.1 specs from the 3.0 specs. And he ran a conversion on them all, which did things like clearing up the diff markup and so on. So we started with a clean sheet in terms of diffs. And he got it wrong, and he got the encodings wrong, and all the non-ASCII characters got corrupted. And it took us, it wouldn't have been a problem. We'd have done it again if we'd noticed, but we only noticed a year later, by which time we'd made lots of other changes. But the tools helped us solve the problem. Because you can actually run a query against this document and find all the non-ASCII characters. It's not difficult. And if you've got that kind of tooling, then that sort of problem becomes fixable. So even in little things like that, the tools kept helping us when we needed help. They got us out of holes. So that's some of the technicalities of the actual document production process. I didn't mean to do that. Actual process and tools, what did we use? Well, there's a lot of legacy here. I mean, this process started 18, 19, nearly 20 years ago, and the tooling was different then. And you don't change your tools unless you've got a strong benefit in changing your tools. So some of this is pretty old stuff. CVS, good old CVS. Not what we'd choose today, but it does the job. We've moved some stuff over to Mercurial more recently, and we can see that it's a hell of a lot better. But you have to be a hell of a lot better to justify the investment in actually someone taking a week out to get rid of old technology and put in new technology, and so it never happened. So it's all using CVS as the baseline. The worst thing for that is that CVS is control of, well, firstly, CVS was designed for programs, not for documents, which is one of the problems. We're using a lot of technology here that was designed for software development, not for document development. And CVS is just no good at managing very large objects with small changes where multiple people make changes and you want to merge them. Particularly given this point here, any XML editor you fancy. So if two people are editing the document using different editors and then you diff the results, then most of the diffs are just accidents of formatting that result from the fact that they were using different editors. So it can be quite hard to merge changes made by different people. Most of the validation is DTD based. Back in the early days, we used the same DTD as was used for the XML spec itself, originally written by Eve Mailer, then developed by Norm Walsh, and subsequently added to by a lot of people, and it's forked several times for different versions of specs and so on, but it's still essentially that original DTD. It has some support in Oxygen, which helps for those editors who choose to use Oxygen. But there's a lot of XSLT validation as well. No schematron in there. I think just because that would be one more technology to learn and to use, and everyone knows XSLT, so why not use that? But there's a lot of checking of things in XSLT style sheets. For example, somewhere in the production process, there's a rule that checks that none of the line lengths in examples exceed 90 characters, because we found that was a reasonable limit for formatting on quite a wide range of devices. So if you try and have examples with lines longer than 90 characters, then you'll get warnings out of the build process. And that's an XSLT rule, rather than, obviously it can't be written in DTD, but it could be written in schematron, but it isn't. The styling is CSS, and the styling changed on us at a very late stage of the production process. Right at the final candidate recommendation, we discovered that W3C had changed all its style sheets. And by and large, that didn't cause us any trouble. The area that it did cause us problems was in table formatting. Because table formatting, it is really a bit difficult to separate content from presentation entirely. And just putting in a new CSS style sheet won't get all your tables in the way you want. You've got to go back to, and we'd got a lot of format-oriented markup in the tables as well that we needed to tidy up and get rid of. But by and large, CSS definitely proved its value in serving its purpose of enabling you to move to a change of presentation format across the whole family of documents without any change to the source code. The pipeline technology is all ANT plus XSLT. I'll talk a little bit about the scalability of that. Editors use any XML editor they like. The issue tracking is all in Bugzilla. And then there's back-end QA that says we can't publish a document until we've been through some W3C level quality assurance checking. That includes checking we've got valid HTML5 that we're pushing out at the back end. Link checking that all the links resolve to somewhere, including the external links as well as the internal ones. And this thing called pub rules, which is doing, I can only call it QA checking. There's a rule that says the status section of the document has to have a link to the W3C patent policy. And to say which version of the patent policy that it's referring to. The pub rules checker will check that your status section has a link to the patent policy. It's got, a couple of hundred of such rules. And sometimes they work and sometimes they don't work. You sometimes get false negatives because it is doing a sort of free text analysis on what it finds in the document. So it can be a pain getting through that, because sometimes you think, I'm sure I satisfy this rule, why the hell are they rejecting the document? And you eventually find out why. But that's all written in XSLT as well. And it's something that we, as a working group, don't have any control over. It's something that's imposed on us. So that's the process and tools. The actual building this collection of documents, just going through the repository, I found 300 style sheets in there. I don't know how many of them are used. That does cover multiple versions of the specs, because there's all the 1.0 specs there as well, and sometimes, sometimes the thing is forked, so that the 3.1 version is forked from the 3.0 version and so on. So there's repetition in there. About 7,000 template rules. I found 74 ANT build files containing 947 targets. Target being a step in a build file. So yeah, over the years it grew like topsy. No one controlled this process. Individual editors exercised personal responsibility and discipline to try and make sure that they reused as much as possible. But sometimes, someone felt that they needed a variant of something that was sufficiently different, so they went and created a variant, and it was never retrofitted back. So things fork a bit over the time. 596 other XML files, including the main source files and other bits and pieces. Just to give you an example of some of the bits and pieces. In the XSLT spec, there's a little grammar for every element that says what attributes it has. We don't use the XML schema to control that. We have our own little mini schema language, which James Clark invented for XSLT 1.0, and we've carried on using. And so there's a document that has a summary of the syntax and of the elements and attributes. That's used to generate the spec. It's also used in some other interesting, it's also used as input to the validation. For example, we have a test in the validation suite that every element attribute pair that is permitted by this syntax appears in some style sheet somewhere in the test suite. So that's one of the tests, is testing the test suite to make sure that it's complete in terms of the element attribute combinations that are permitted. So it's the kind of added value that you get from having this data in semantically marked up XML rather than just in narrative XML. Where did I get those numbers from? Got those. For once, I used XQuery. I do use XQuery. There's nothing wrong with XQuery. It has its uses. That bit, I got those numbers using XQuery. I plead guilty. Here's an example of an XQuery. I don't know how to expand that in terminal. Does Command plus do it? Yes, it does. No, it sent it off the screen. So that's running a command line query using Saxon. It does a count on the collection of XSL documents recursively within my current directory, and then finds the template elements within them and does the output. So that's searching the whole repository for XSL template elements within style sheets. And it's disappeared off the screen again. I've just run the wrong command. I shouldn't have changed this font, should I? Because I can't see what I'm doing. That should do the right thing. Yeah, so that's come up with the very badly formatted answer, 7188. But in order to use slides, you don't need it to be well formatted, you just want the answer. So that says there's 7,188 template rules in the style sheets in this repository. I've done the same, did the same to get the word counts. And actually I'm very pleasantly surprised with how quickly those queries run. You're searching a pretty large database of material, and it's searching a large number of files, and it's running, it's doing XML parsing on each of those files, it's running XPath expressions against each of those and coming up with an answer, and it works very well. And the dog food argument, well, when I was preparing these slides the other day, I ran that query using Saxon, whatever the latest release is, 9.8, I'm losing count, and it crashed. And I found a bug. It was a bug that said, if you're using the collection function in Saxon EE with asynchronous processing enabled, with parallel processing enabled, and there's an option, and there's an invalid XML file in your collection, then the threads don't terminate properly. So it's a little bug concerned with the parallel processing in the enterprise edition of Saxon and the situation where you've got non-well-formed XML. So a particular collection of circumstances. I found that bug before any of you found it. Why? Because we're using our own dog food to process these specs. So that's just a little example of the kind of benefits that we get. It's not just spec benefits, but it's product benefits as well. The fact that we're using the technology every day means that we hit that kind of thing before you do. So that's about building the documents. What lessons? Firstly, this stuff works. We've used it. We've proved it works. We've shipped the documents, and I think we've delivered a technically quite sophisticated set of documents. I've learned a lot about the development process, about the sort of creative chaos as to how you develop this stuff. It's not top-down design. It's based on individuals doing things when they need to get things done. You can't schedule time or allocate resources to this. You've got to rely on people seeing there's an opportunity here to develop a bit more tooling and share it with the rest of the community. And then this dog food effect that I've mentioned. So other things, that's most of the talk is about the document production. Managing the grammar, Hirko's told us a little bit about handling grammars with XML, and the Rex technology has been used on this as well, but the mainstream W3C process hasn't actually been using Rex. One reason being that Rex is not actually properly released on an open source license that would be acceptable to W3C. That's one of the issues. The other is simply that we started earlier. So what actually happens is we've got a grammar file that holds all the grammar of XPath and XQuery and XSLT patterns and the extensions for update and full text. This is what it looks like. So there's a couple of production rules for XQuery update there, for replace expressions, rename expressions, etc. So it's an XML representation of the BNF grammar rules for the languages. And they've got these if clauses to say which languages they apply to, because we're managing the grammar for 7 different languages in one master file. And that's used in the W3C process for 2 things. One is to generate the production rules in the actual specs, and the other is to generate a parser, which is actually a Java parser. It's generated using, by generating BNF that's fed into the Java CC tool, which produces a Java parser, and that Java parser is used to produce the applets, which are on the W3C website, which you can use for testing fragments of grammar and seeing how they parse. So that's pretty ancient technology now, but it's there and it works, so I change it. But having got the benefit of having the grammar in that form, it's also been used to generate grammars that can be input to more modern tools like Rex. And I think quite a few XQuery vendors actually have their production parsers in their products derived by some kind of transformation process from this grammar in the specification. And if you're an implementer, then that's a very good way of ensuring that you have actually implemented the grammar that's in the spec by actually taking the source and transforming it into whatever parser technology you use internally in your product. The third thing that it's used for is some validation. So part of that process of processing the grammar is checking for ambiguities, checking for the amount of look-ahead that you need. The number of times I can tell you that someone's produced a change proposal to the XQuery grammar and said, we want to add this feature. And someone like Michael Dick, who in recent times has been the expert on this technology, has come back and said, no, you can't do that. That's ambiguous. Here's an example of what won't work. Charles is telling me I've run out of time. Let's push on very briefly to just say one or two words about managing the test suites. We've got about 20,000 XPath tests, 10,000 XQuery tests, 10,000 XSLT tests, a large amount of material. It's all XML, all the metadata. The interesting bits are how the dependencies are managed and how we manage results. We don't use XSpec, but it's influenced by XSpec and reuses some of the ideas. So here's a little bit of a test set to get a feel. This is an XSLT test case. It's got a description, it's got keywords, it's created by Abel on a particular date. It's got an environment which tells you what source documents and schemas you need to use for that test. It's then got dependencies that say you can only run this test if you've got an XSLT2 processor that's schema aware and that supports German date formatting or things like that. So there's a lot of potential dependencies you can put. And the idea is that if you're an implementer, you can use that either to configure your product so that it supports German date formatting and is schema aware, or you can use it to say, I don't support that combination of dependencies, I'm not interested in that test. So you don't have to run all the tests, you can only run those that are applicable to your product. And then it's got result assertions. In this case, the result assertion is a bit of XPath. So a very flexible mechanism for saying what the expected results of the test are, which of course can be errors as well. We'll probably find there's an error case very soon. Yes, there's an error case that expects that particular error code from that test. So that's the way the test material is managed. Implementers run the tests, they submit reports, and we then have an XSLT style sheet, of course, to analyze the results. And at the back end of that, we get a report on test results, which looks something like that. And it tells us, for different people who've reported results against the test, how many tests they claim to have run, how many they claim to have passed. And we can drill down and say, well, how many people have implemented higher order functions? And you can click on a link there. Well, you might get an answer. I think that's probably an internet connection issue. But basically, you can drill down onto what the test failures are and which tests aren't being passed by enough implementations and what problems they're reporting and so on. And that was used as part of the W3C management process to say, are there enough implementations of these specs, and are the implementations interoperable with each other to a sufficient degree? So that's very much part of the W3C quality assurance process that says you've developed a spec that's implementable and the implementations have a good enough level of conformance to it. So I've run out of time. I always do. Sorry about that, but thanks very much.
Thank you, Michael. So next up we have starting our expert panel session. Let's go on, Abby.
Oh, sorry. No, if there's no time for questions, okay.
We could have time for maybe one quick question.
Oh, well, first of all, I want to compliment you for the 207,000 words on the XSLT 3.0 spec. And I just checked out, this is as large as the Order of the Phoenix from Harry Potter. Really darn book you've written there. The other question is, any of those tools, or all those data, the XML files that you showed, are they publicly accessible, or is that not available?
Some of them we've published, like the schemas for the spec and so on. In general, I think they aren't accessible other than to W3C members. I think Sharon may be able to correct me on that, but I think that's the formal position.
Because your own dog food would also be like an example as a showcase for using XSLT or XML and all the other.
No, it's a good question, but in general, I think it's W3C member only. Thanks. Okay. Thanks a lot.